In this video, I show how you can build a learning mechanism into your AI automations so that every day they get smarter and smarter based on your feedback. For example, with this learning mechanism, I was able to increase the success rate of this AI marketing automation from 75 to 98%. Or the success rate of this AI recommendation system right here from about 67% to 95%. And you can use this learning mechanism to optimize almost any type of AI automation or almost any type of AI agent and take it from being good to being close to perfect. And the best part is we will build this learning mechanism into the entire system so that once it is set up, you don't have to change anything about the workflow or the prompts to improve it. You just have to provide additional feedback and examples that the AI can learn from. And I'm now going to show you exactly step by step how to build this in n8n, so let's get started. Okay, here I am inside of n8n, and this is the workflow that I'm going to demonstrate this automation technique to you today. But again, once you understand the idea, you can use it to optimize almost any type of automation or almost any type of AI agent. What you can see here is an AI recommendation system, and the way this works, people can fill out this form right here with their email, and then they can enter some information about a website project that they want to build. And then the AI will, based on their requirements and their technical expertise, recommend the perfect website building platform to them. And if we have a look at the prompt here, you can see this is the prompt that I gave to the AI with some instructions, what it should do. You are a website builder recommendation expert. And then I gave it a list of 8 platforms that it is allowed to recommend. So for example, WordPress, Webflow, Framer, Web Studio, Shopify. And for each platform, I gave it a list of bullet points with advantages and disadvantages that the individual platform has. All right, let's try this out. I'm going to execute the workflow and then enter some information into the form. I'm going to write, I want to build a small one-page online shop to sell my 3 dog food supplements. I want to use a nice template and want to finish this within 1 weekend. Okay, let's submit the form. Okay, the automation executes successfully, and let's see what the AI recommended here. So here is the response of the AI. Here are our requirements. This is what I just entered. I want to build a small one-page online shop for my dog food supplements. And the platform that the AI recommended is Shopify. And the explanation for that is Shopify is the best platform for e-commerce, offering templates and quick setup for online shops. So you can see in that case, this is actually quite a good recommendation. The problem is, however, as you will see in a few moments, this AI makes a lot of mistakes. And the reason for that is because it has a limited amount of information about the scenario. So we have a couple of paragraphs about these website builders, and based on that, it has to come up with its results, with its recommendations. All right, I've now loaded 12 testing requirements into this note here, right here. You can see I've pinned 12 items, and these are just 12 imaginary website requirements for all different types of website projects that people want to build. So you can see, for example, we have a law firm that wants to build a website or someone that needs a small landing page and so on and so forth. And let's execute this and see what the AI recommends. Okay, the AI has finished executing, and let's have a look at the results. So here on the left side, we can see the requirements that were entered into the form. And then in the middle, we can see the platform that the AI recommended. And then on the right side, we can see an explanation. And you can already see in a lot of these cases, the AI recommends Webflow. So it almost seems to over-recommend Webflow as a platform to build a website with. And Webflow is a great website builder, but it is also quite technical. So for example, here we have a freelance videographer with some creative Adobe software skills, but Webflow is going to be way too technical for them. Or this example here, we're a boutique hotel that needs some website with a booking engine and things like that. I don't think Wix is a great recommendation because Wix is like a easy to use website builder, but it's not suited, in my opinion, for a boutique hotel that needs something really custom. So you can see the AI has the right idea, but usually the final recommendation is not that great. So let's think about how we could improve this. And the best way to approach this is to ask ourselves, how would we tell a human to improve their results? Let's say you had given this task to some person and they then came up with these results, with these recommendations right here. Well, what I would do to improve that person's results, I would just give them a list of examples with imaginary website requirements, and then what I would personally recommend in that situation. And then also a short explanation why I would recommend that platform in that specific situation. And he will then have a much better idea what I actually want from him. And the amazing thing is, we can do the same thing with AI. We can set up a mechanism that provides relevant examples to the AI whenever it analyzes a new input. And now in the next few minutes, I'm going to show you exactly how you can build this mechanism to provide examples. All right, let's have a look at how we can do this. What we're currently doing is what I call the prompt-only approach. So we have our input, in our case, the website requirements, and we feed that into the AI alongside some instructions how the AI should respond. And just based on this information in the prompt, it has to come up with a recommendation of one of these 8 platforms. And as you could see, the AI, the responses usually go in the right direction, so they are okay or maybe good in some situations, but they're not really that great, let alone close to perfect, where I would ideally like my AI results to be. So the first step that we could take to improve this is an approach which I call prompt plus static examples. So what we can do is we can create a list of examples that we write into this prompt. And the way these examples are structured is every example will have an example requirement, so a short text about some imaginary website project. Then what I would recommend in that specific situation, so for example, Shopify, Framer, Webflow, WordPress, and things like that. And then a brief explanation why I would recommend that website builder in that specific example scenario. And then we would just write this list of examples into the prompt. And then whenever we analyze a new input, a new website requirement, the AI would now have a little more understanding of what we want from it. So with this approach, we are going to get better results. However, this approach has a couple of problems. And I've written all of these down here. First of all, we can only write a limited amount of examples into this prompt right here. Recent studies have shown that you can put about anywhere between 5 to 20 examples into your prompt, depending on the use case, before the results start to degrade. So if you then put more examples into the prompt, the AI is actually going to give you worse results because it is just overwhelmed with too much input. So we really have to limit the amount of examples that we put in here, maybe 5 or 10 or 15 maybe. But this immediately causes a second problem, and that is our examples are not going to be super relevant. If we can only put 5 or 10 examples into this prompt, then for lots of scenarios, for lots of website requirements, there will not be a super relevant example in our list. And then that means in such situations, our examples are not going to be super helpful for the AI. Which immediately leads to the third problem, and that is our prompts are going to get quite expensive. Because in order to maximize the chance that for any given input, for any given website requirements, we have at least 1 or 2 examples in our list that are at least somewhat relevant to the input, we have to put in as many examples here as we can. So maybe we put in 10, 15, 20, maybe even 25 examples into here, just so much that the problem number 1 does not kick in, that the results of the AI start to degrade. But if you put so much examples into your prompt is going to get really big. And as you might know, all of the AI providers, they charge based on input. So the more we write into the prompt, the more expensive this is going to be. So you can see this approach, while it gives us some improvements, is not going to get us where we want to be. Which is why today we're going to have a look at this third approach, which I call prompt plus relevant examples. And this will get you absolutely amazing results. So let's have a look. What we're going to do here, we're going to create an examples table, so kind of like an examples database in n8n. And in this examples database, we put in as many examples as we want. We can put in 100 examples here, thousands of examples, it does not matter. And then every time we have a new input, when we have to analyze a new website requirement, what we do, instead of immediately sending that requirement to the AI, what we do instead, we first send it to this example table. And then we tell this example table to look at this requirement, to look at this input, and return us the 5 or 6 most similar examples in this example database. So then we have a list of 5 or 6 really good, really relevant examples for that specific input, and only then do we send the input to the AI together with these 5 or 6 really good examples. And then we analyze the next website requirement, so website requirement number 2. We do the same thing. We again send it to our examples database, then tell the examples database, hey, now please return us the most relevant, the most similar examples to this website requirement number 2. And that could be completely different examples than for website requirement number 1. And then we send website requirement number 2 into the prompt together with its most relevant examples. And this approach immediately solves all of the problems that we had in approach number 2. So if I copy this here, limited amount of examples is no longer an issue because in this examples database, we can put in as many examples as we want. Even if we have 1,000 examples here, it does not matter because whenever we run this system here, we only pull out the 5 or 6 most relevant examples anyway. So limited amount of examples is no longer an issue. Also, the second problem is immediately resolved, non-relevant examples. If we can put thousands of examples in here, we can create examples for any type of imaginable scenario. So whenever a new website requirement comes in, we will always find some relevant examples to it because we just have such a huge amount of examples to choose from. And the same with the expensive prompts problem. Now that for every input, for every website requirements, we get extremely good and extremely relevant examples, it is enough to put 5 or 6 into the prompt. Because as you might know from your personal life, if you have a handful of really good examples, usually that is more than enough to work effectively on a task. And the same holds true for the AI. But the best part about this entire setup here is that this automatically has a learning mechanism built into it. Because what we're going to do after setting this up, for a few days, we're going to monitor the results of the AI. And then we're going to see in which areas does the AI make mistakes. So what type of input is it not really good at dealing with? And then we just create new examples for this specific type of input that the AI struggles with. And then in the future, when we get a new input like that, the system will pull out these new examples for that specific type of input. And then the AI will no longer make that mistake anymore because it has much better examples and knows much better what we want from it in that specific use case. And this way you can keep monitoring the AI and step by step provide better and better examples for all different types of areas that it struggles with until the results get close to perfect. All right, let's have a look how we could build this in n8n. So the first thing that we need to do now is we have to create our examples database. And n8n has recently added this new feature called data tables. And this is basically just a table application like Google Sheets or Airtable, but built right into n8n. To create a new data table, you just click on this down arrow here next to create a workflow, and then you click create data table. Let's give it a name. I'm going to call it website recommendation examples. All right, now we have to create the structure of the table. I'm going to add a new column up here, and I'm going to call this requirements. So there we put our example requirements, type string, and I add the column. Then we need another one. This is going to be the recommendation that we personally would have made for a specific example requirement. So I add this column. And then we need a last one, and this will be the explanation column. So here we give a short explanation why we would have made a recommendation for a specific example requirement. All right, and now all we have to do is we have to fill this example database with some content. So let's start out with the scenario that I entered in the beginning. I need a simple one-page shop where I sell my dog food supplements. And in that situation, I would personally recommend Shopify. And the explanation for that is Shopify is a good solution because they can easily spin up a small shop without too much technical setup. So just a very brief explanation for our recommendation that we would personally give in that situation. Okay, and then you just keep going. Usually I recommend for these type of systems in the beginning to start with 10, 15 or 20 examples. And then later when you start to monitor the AI and see where it makes mistakes, you then add additional examples for the areas where the AI struggles with. Okay, here's another example that I'm creating. I want to build a website with minimal effort. It is a simple landing page which should showcase my course. I have technical experience. In that situation, I would recommend a website builder called Card. This is kind of like a niche website builder that specializes in simple one-page websites. So it's really good for that. And this is actually exactly what I'm going to write as an explanation. Card is the right choice here, works extremely well for simple one-page websites. And now we just need to keep going until we have about 10 to 15 examples that we can start with. All right, I've now filled this table with lots of example requirements and then what recommendation I would personally give in that situation, and also an explanation for why I would make that recommendation. Now, before I show you exactly how we can load these examples from the data table into our AI, I quickly want to point out that I'm currently adding a new chapter about data tables to my course Technical n8n Simplified. So if you're interested to learn more about these and also other technical aspects and fundamentals of n8n that I teach completely from scratch in this course, then check out the link in the video description. Okay, so now we somehow need to load these examples from our example table into our AI. And this is not as straightforward as it seems, because remember, what we want to do is we only want to get the most relevant examples out of this table for every input that we then later put into the AI. The problem is with these data tables, they are great at managing the examples, creating new ones and editing them, but they do not have this ability that we can send an input and then have it search based on similarity. So these data tables, or also other table applications like Google Sheets or Airtable, they do not have this feature that you can search something based on similarity. Which is why what we're going to do is we're going to keep using this data table to manage our examples, to edit them, to create new ones, but we're going to synchronize it with a so-called vector database. And this sounds much more complicated than it actually is. You will see in the next few minutes this is not actually very difficult. And this vector database will then also contain all of our examples because we synchronize it with it. But on top of that, this vector database has the ability to do the similarity search. So with a vector database, we can send some input, or in our case, some requirements, and then it can perform a similarity search based on all examples and only return us the most relevant, the most similar ones to our input. Okay, so to synchronize our examples table with the vector database, I'm going to click here on plus and create a new workflow. And here I'm going to add a trigger, a schedule trigger, because I want to run this synchronization automation every single day. I call it every day, and the trigger interval is days and days between trigger 1. And then every day I get the examples from the examples table. So data table, I'm going to get the rows, and I will call this get new and edited examples, because I only want to pull out examples that have been recently created or recently edited. I want to return all examples where that is the case. And I also have to choose a table here. I'm going to choose the table which we created called website recommendation examples. Then we have to add a condition, and this condition basically filters our result. And here I'm going to choose updated at, so when a specific example was last edited, and the condition is updated as must be greater than, and for the value I switch this to expression mode, and then I write $now dot minus 1 day. So all this does is it checks if an example was edited or created within the past 1 day, and if that is the case, it will pull it out of the example database and give it to us. And by the way, with regards to these expressions, so this $now minus 1 day, there's also an entire chapter in this technical n8n course that I previously mentioned, where I talk about these expressions. So if you're interested in learning more about them, then feel free to check out the link in the video description. All right, so let's try this out. I'm going to execute the workflow, and we get 10 items back. So these are all of the examples that I just created. And that is not surprising because obviously these examples were created in the past day, so they will be returned here. And all other examples that might have been created or edited more than a day ago, they would have already been handled by a previous execution of this automation. All right, then I create a set node here, and I'm going to call this set node example item. And here I just want to extract the most important information from the example. I need the ID, I need the requirements of the example, I need the recommendation, and the explanation for the recommendation. And the other fields created at and updated at, we now no longer need them in the next steps of the automation. All right, let's execute this. And you can see here we have our simplified example data. And now we have to load each example individually into our vector database, which is why here I add a loop. And the reason why I add a loop and do not rely on n8n's default looping behavior is because we have to load each example individually into the vector database. So let's call this loop over examples. And then for the loop output, I add a Supabase vector store, and I choose the action add documents to vector store. And let's rename this to example vector database, examples vector database. And here we now have to connect Supabase. And to do that, you just click on credential to connect with and create a new credential. And we need two pieces of information here. Number one, the host and the service role secret. And we get that from the website supabase.com. Supabase is a database platform, and their database also includes this vector database functionality so that we can do the similarity search. You now have to quickly create an account. Just click on Start Your Project. And then here click on Sign Up Now and enter your email address and everything else that you need for the account creation. Then once you've created your account, you will receive an email where you can confirm your email address, and then you will automatically be redirected to this page right here. There you have to create a new organization. I'm calling this Mike's organization. You can call it whatever you want. And for the plan, I choose free. And then you click on create organization. Then you have to create a new project. The project name, I just leave it as is. And you have to create a database password. I recommend you to generate a password here. And then click on create new project. All right, here we have our new project. And we can now go to the SQL or SQL editor. And here I want you to paste in the following code snippet to create our vector database. I will make this available to you in the video description as well so that you can just copy and paste it. In this case, I want to call my vector database examples, and the method to later pull out the most similar examples, I want to call relevant examples. That's important. We have to remember that for later. And what's also really important, I set this dimension here to 1024. We have to remember that, because later we will need this dimension number. And then make sure before you click on run that it does not say run selected. If that is the case, you have a specific text selected, then just click anywhere inside of this code, and then it should switch to run, and then you can execute this code. It says success, no rows returned. And if we now go to our table editor, we can see we have a new table in our database. Right now it says unrestricted, so it has this red label here. To fix that, just click on RLS disabled at the top and enable RLS for this table. Okay, and this is now the structure, the shell of our vector database. And if you don't understand what these individual columns here and what all of this means, then don't worry. In a few minutes, I'm going to give you a more detailed explanations what vector databases are, and especially how these vector columns here work. But right now, I want you to go to the project settings, because in n8n, we still have to connect our Supabase account, and you paste that project URL where it says host. You have to click on API keys here, and then on API keys, and then click on create new API keys. And now we have a new API key. And paste it here inside of n8n where it says service role secret, and then save. Connection tested successfully, which means we can now close this. Then we have the ability to choose our table. In our case, that was the examples table that I just created. So that's what we're going to use as our vector database. Then we have to add an embedding model. And here I choose OpenAI. And the model I want to choose here is text embedding 3 large. And for the option, I want to add dimensions and choose 1024. So remember, here we have to put in the same number as during our setup of the vector database. And this embeddings model, this AI model, is a specialized model that allows us to turn a piece of content, in our case some website requirements, into a vector. Again, in a few minutes, I'm going to give you more details on what a vector exactly is. But let's finish this. We also need to add a document loader here. Please choose default data loader. and then switch the mode to load specific data. And then where it says input, you choose mapping and then go to our examples item. And then you just want to pull the requirements here. So this is the data that we will later base our similarity search on. Then add an option, metadata, and then add four properties, because what I want to do alongside of storing these requirements here in the data of this vector database, I also want to store the entire example in my metadata so that we always have it available and can pull it out when necessary. So I'm going to start with the ID and the name of the field, I give it ID. Then the requirements, pull in the requirements, recommendation, pull in the recommendation, and the explanation, I pull in the explanation here. Okay, and then we need to do one more thing. We have to switch the text splitting from simple to custom. And then what I want you to do is I want to add a token splitter and just set the value to a high number like 5,000. This just ensures that for each entry in our examples table, this will create one entry in our vector database instead of maybe splitting each example into multiple entries. All right, and then we can complete this loop here. And you can see all of our 10 examples were successfully loaded into the vector database. Let's have a look at it. Then we have the metadata. So here in the metadata, you can see we will find our example data. So our recommendation, the requirements of the example, the explanation, and also the ID, alongside some additional metadata that n8n has created. And then finally, the really interesting column is this here, the embedding. So what is a vector? A vector is just a long list of numbers. And in this case, this list of numbers represents the mathematical meaning of a piece of text. So for example, this list of numbers here represents the mathematical meaning of this piece of text. This list of numbers represents the mathematical meaning of this piece of text, and so on and so forth. And that's exactly what this embedding model that we just talked about a few moments does. It takes a piece of text and turns it into a mathematical meaning of that piece of text. And this is really powerful because this mathematical meaning, so this list of numbers, is something that can be easily compared to other lists of numbers. So what the vector database does, whenever it now receives a new input, a new website requirement, it will turn this into a long list of numbers, so into the mathematical meaning of that piece of text, and then compare it with the mathematical meaning of all of our examples that we have stored in our example database. And then it will pull out those examples that have the closest mathematical meaning to our new input. And that means, in our case, it will pull out the most similar, the most relevant examples to our website requirement that we want to analyze. So this is the mechanism how a vector database works. All right, now we have to make a few final adjustments here to this automation. First of all, we want to make sure that whenever an example is loaded into the vector database, that the old version of that example is deleted first, because otherwise we would create lots and lots of duplicates, and this would not be good. So here I'm going to add a note, and I want to search for Supabase, and the action is delete a row. For the table, I also choose our examples table, and the select type I switch to string. And here please paste this exact text inside of this field. What this does, it basically makes sure whenever we want to save a new example to the vector database, that we, before that, only delete those examples that have the same ID as the new example that we want to add. And this just makes sure that we do not delete all examples in the vector database when we add a single new one, but only those that have the same ID, so the old versions of these new examples. Then we also have to go to the settings here and turn always output data to on. And the reason for that is, whenever we create a new example, obviously this example does not have an entry yet in our vector database, but we still try to delete it. And in that case, if you try to delete an example that does not exist, this node right here would not return any output. But as you might know in n8n, when a node does not return any output, the nodes after it cannot execute, and thus this would bring our automation to a stop, which is not what we want. We want this to fully execute. And this is why we have to activate this setting here. And what we also have to do is we have to add a limit node in here. Because what sometimes can happen when we delete a row or let's actually rename this to delete example or delete old example. I think that's the most descriptive name. So when we delete an old example and for some reason there are already some duplicate entries for that example in the vector database because we made some mistake or something like that, then this node here would return multiple items as output depending on how many duplicates it deletes. But then this right here would receive multiple items as input and thus would execute multiple times and would just add the duplicates again into the vector database, which is why I add this limit node here to limit the amount of items to 1. And if you don't yet fully understand what I meant when I just said a node executes multiple times when it receives multiple inputs, or the automation stops when there is no output, this has something to do with how data works in n8n. And I've actually also created an entire chapter about this topic in my course Technical n8n Simplified. So if you're interested, again, I'll put a link to that in the video description. Okay, now let's make this look a little nicer. And now this automation is almost complete. There's one final thing that we have to do. If you are on the free plan of Supabase, the only really annoying limitation of the free plan is that a database will deactivate itself after 7 days of inactivity. So what I'm going to do here is I'm going to create another trigger, and this trigger runs every 6 days. If you have a paid plan of Supabase, you don't have to do this, by the way, but for the free plan you do. So every 6 days, this trigger will execute. And then what we do, we will pull one single example out of our data table. So let's rename this to get one example. Doesn't really matter which example it is. We just need a single one. So I delete all of these conditions here, deactivate return all and set the limit to 1. And then I connect this to this example item. And this means every 6 days, this automation will now pull out a single example and save it into the vector database so that at least once a week we have a small mini operation and then your vector database will not be automatically deactivated. Additionally, one final optimization that I want to make here, in the condition for the get and new and edited examples, I want to set this from now -1 day to now -2 days. This just adds some additional redundancy that if for any reason on one day the loading into the vector database does not work, then it will try again on the next day. So this way we improve the reliability of this entire system here. Let's save it. And now let's run a final test. I execute this workflow here. And all of our examples are successfully loaded into the vector database. And if you reload this, you can see no duplicates related because the old versions were deleted and only then the new ones were added. All right, and then you can activate this, and you also have to set up some error workflow and things like that. I'm not going to do that now. This is quite simple. You can do that on your own. All right, and now it gets really interesting because now we can finally load the most relevant examples into our AI prompt. And the way we do this is I'm going to add a loop here again because we have to pull out the most relevant examples for each new requirement individually. With a form, usually you only get one item at a time, but if you get your input from some other source, then you definitely have to set up this looping mechanism, so you might as well set it up right from the start. So loop over requirements. And then for each requirement, I want to add a Supabase vector store node here and choose the action get ranked documents from vector store. And this one I call get examples. The table name, examples. Then we have to fill out the prompt. I'm going to do that in a moment. First of all, let's add an embedding model here again. And here we have to choose the exact same embedding model as we did with the other workflow. So I'm going to choose text embedding 3 large for my OpenAI embedding and then add dimensions 1024. Let's execute all the previous nodes so we have the data available. Problem running node. Okay, I'm quickly going to have to fill out some dummy data here so that this works. All right. And now we can pull in the website requirements that we get from the previous steps and put it into the prompt. And the prompt here is basically just what we want to base the similarity search or the comparison on. So this text right here, this prompt will again be turned into mathematical meaning and will be compared to the mathematical meaning of all of our examples. And as we just said, the mathematical meaning for each examples is the mathematical meaning of the example requirements. So for this content right here. So that's how it can find the most similar ones. Okay, now the limit is set to 4 here. So this just means how many examples do we want to pull out? Do we want to get the top 4 examples? Do we want to get the top 10? And I think in this case, 4 is actually a good number. Then we need to add an option for the query name, because the default query name is match documents, but when we created our vector database, we renamed it to relevant_examples. So that's what we have to fill out here as well. Let's execute this step and see what it does. And you can now see for this new requirement here, I need a very simple one-page landing page. I'm a bit technical, but not overly. I want to finish it this afternoon. It pulls out these 4 examples. So here we have the examples, then we have the metadata, and on the right side we have a score. And this is a number between 0 and 1, and it represents the similarity between our input and our examples. So 1 would mean the example is exactly the same as our input, and 0 would mean they are completely different as it could be. Let's simplify this data here a little bit. I'm going to move this over here and then add a set node to simplify the data. Let's call this ranked examples. And I will add a few fields in here. First of all, I'm going to pull in from our requirements the new example that we're analyzing. This field is called information here, but I'm going to rename this to requirements. Then from our vector database again, I pull in the score and I call this relevance. And what I also do is I will multiply the score by 100, and then this score represents a percentage. So 100% would mean it would be exactly the same, and 0% that it is completely different. And let's also, what I'm doing now, you don't have to do this, but I'm also going to wrap this in some parentheses and then write .toFixed and then 1, because we do not need it perfectly exact. We just need 1 position after the comma. And now what I do is I pull out all the example data from the metadata, because remember, we not only stored the example requirement here, up here in the content of the vector database, but we also stored the entire example data in the metadata. So now I can pull it back out again here. So let's pull in the example requirements, and I call this fields example.requirements. Then I pull in the recommendation and I call this example.recommendation. And then finally the explanation. Oops, let's delete this empty field here. And I call it example.explanation. Let's execute this step. Okay, there's still an error because I have to switch this to a string, because I added this percentage sign here. So it's no longer a number, but text. So let's try it again, execute step. And there we go. On the left side, we will now see the requirements, the new requirements that we're analyzing. And on the right side, the examples that it pulled out of the vector database. And in the middle, we can see how relevant the individual examples are. So here for the input, I need a very simple one-page landing page. It pulls out the most relevant example. I need a simple one-page shop. So you can see this is quite a similar example actually. And what's also great about this vector database, it returns these examples already in a sorted order. So we can see the most relevant example will always be on top. And then the lower we get, the less relevant the examples get. All right, now what we have to do is we have to aggregate the examples, because right now they are 4 different items. And this would mean if we now were to feed this into the next step directly, then this AI analysis would execute 4 times for each input. And we obviously don't want that. So I will add this aggregate node here. Let's call it aggregate examples. The input field name is the example, and we want to rename it to examples. And if I now execute this, you can see now we get all of our examples in a single item as a list. And now we can close this loop right here so that it executes for all of the inputs that we have. And then afterwards, these examples are sent to this AI analysis step. Let's quickly execute this so that we have all of the previous data available. All right, now we've executed this. The output here does not matter yet because we still have to load in the examples, but now we have all of the data from the previous steps available. And you can see in the done branch from the loop step, we get the most relevant examples for each of our original requirements. And what we can do now is we can do the following. I'm going to add a new section here and write, here are some examples of recommendations that I have made previously for similar website project requirements. And then we just take the examples that we receive for each individual input and drag it in here. And you can see now we get this object, because this right here is an array and not text. But we can quickly fix that by wrapping that in a function called json.stringify. And now you can see we get our examples. And let's also format this a little nicer. I'm going to write null, 2. And now here we have all of our 4 examples displayed as structured data so that the AI can work with. What you can also see, now this is going to be really interesting. Here we have the examples for the first input. So the first input, the first requirement is I need a very simple one-page landing page. If I switch this to the second input, you can see I'm a freelance copywriter is the new requirement we are analyzing. And now the examples that the vector database returned are completely different. So here it now pulled I'm a freelance videographer as the most relevant example. Or here I want to build a website with minimal effort as the second most relevant example. All right, so let's execute our entire workflow again with our test data from the beginning where the AI made lots of mistakes and see what happens. So now it pulls out the most relevant examples for each of these individual use cases. Okay, and here we have our results. And the first thing that I can see, the AI does not over-recommend Webflow anymore. It still recommends it quite often, but not as much as it did previously. Then what I also see, we talked about the beginning, we're a boutique hotel needing real-time room availability and said that for a boutique hotel, Wix is not really the best platform. And now it no longer makes that mistake because I've provided some similar examples to that. It now recommends correctly Webflow. Or here for this freelance UX designer, I'm not exactly sure what it recommended here. I think it recommended Webflow, but now it recommends something else. It recommends Framer because Framer is a web design tool that is very close to the design tools that designers use. So I think that's a much better recommendation here. So you can see just by individually loading very relevant examples into this AI for each requirement, we can massively improve the success rate of our AI systems, of our AI automations, and also AI agents, by the way. So with agents, you would just not use this Supabase vector store block here, but instead what you would do, let's quickly add an agent here so I can show this to you. But instead you would add a tool here, and then here in the tools you could choose the Supabase vector store, and here you could then pull out the most relevant examples for the agent. So that is also possible. But in my opinion, the most amazing thing about this is that this is not static. You can now monitor the results of this AI, which here in the final step, I save all of the AI results into another separate data table. And then I can just monitor the results and see what the AI does. And whenever it makes mistakes for a specific type of input a lot, then I will just add new examples into my example database. And then when such an input has to be analyzed in the future, the AI will have much better examples and will give you much better results. And now I have 2 important things for you. If you want to see how I use this mechanism to build a completely different automation to optimize an AI marketing automation, then check out this video that you can see here on the screen. And then also don't forget to like the video because this signals to me that you want to see more content like this in the future. Okay, thank you for tuning in. My name is Mike. Have a great day. Bye.